Okay, so last time I posted, I talked about the very basics of oxidation and reduction in organic chemistry. But actually, if you look a little bit closer, you can see that primary, secondary, and tertiary alcohols are actually oxidized and reduced differently. So let me show you a quick example. Now, the way I think of it is when something's oxidized, these bonds to hydrogen will be replaced by bonds to oxygen. So where I've drawn in those little black hydrogens, those are going to be swapped out for a bond to oxygen. So right here, if you get rid of this hydrogen, you can make a double bond to this oxygen. So you oxidize from the primary alcohol to an aldehyde. But then you still have that hydrogen right there. Here, let me draw it in. There's still a hydrogen there in an aldehyde, and you can swap out that bond to a hydrogen for another oxygen. So you can oxidize all the way from a primary alcohol down to a carboxylic acid. But as you can see, for a secondary alcohol, if you have two bonds to carbon, there's only one bond to a hydrogen left. So we can swap that bond out for a hydrogen in place of a bond to an oxygen, but there's no other hydrogens here around this carbon. There's already 4 bonds to the carbon. So that's where we stop. And if you get down here to the tertiary alcohol, well, there's no hydrogens that are bonded to that middle carbon at all. It's tertiary. It already has 4 things bonded to it. So there's no way that can be oxidized. So what that means is primary alcohols get oxidized to the aldehyde and then rapidly to a carboxylic acid. It happens really fast. It's not like it stops in between. I just wanted to show you. Secondary alcohols stop at the ketone state, and tertiary alcohols go nowhere at all. They just can't be oxidized at all. I hope that was helpful for you, and if you have any questions, be sure to comment them down below. Happy